Okay, hi everybody. Today I'll be talking about stubs, mocks, and spies. First, let me introduce myself. My name is Stanko. I'm a Ruby on Rails engineer and all the usual buzzwords, but lately I have become a testing evangelist, which leads us to the topic of stubs. Has anybody here used stubs, perhaps? Okay, so then I won't have to explain that much. Well, basically, you can think of stubs as predefined answers, but let's start from the beginning. Here we have some code. This is a simple Ruby application that basically generates PDFs, nothing really smart, and it attaches them to the order item. People, when they try to test it, or usually what I saw people do when they want to test this, is to write a test like this. Basically, they just create an object and test if the service returns something that's like semi-expected. The problem with that approach is that that test depends on many external services or objects, which can lead to an unstable test suite. Well, to alleviate that, we can use stubs. Basically, we can say we allow other objects, for our spec at least, we allow other objects to receive message calls and return predefined answers. Those are stubs. Yeah, all the examples I will be giving will be in Ruby and RSpec, but all the concepts apply to most major languages, and all the concepts can be used in most testing frameworks. For instance, Mocha and in Java and such forth. So, as I said earlier, we do return always predefined answers. Why is this important? Well, this way we can control the flow of our application. So instead of trying to figure out how we can craft a huge data packet or an input that will cause an error, we can just say, OK, return an error. And this way we can test like everything. This leads me to doubles. Doubles are an interesting concept because when we think about stubs, we can actually stub out something that does not exist. So if you're working on a piece of code and another team is working on another piece of code, and you don't know if that's finished, if it's stable, if it works, but you know it exists and what its interface is, you can create a double for it. This is really important because then you can create your own test your own logic, give it a double, and it will work. Basically, doubles are just empty objects which stub out an interface. So that's nice. Which leads to mocks. Mocks are perhaps the most useful feature here. If we think about mocks usually in different testing frameworks mean different things, but the canonical definition is that we test if something happens with mocks. So for instance here, we test that we return something that's not nil. So we return something. That doesn't tell us much. We don't know if the object got updated, if it got saved, if it failed, if the database returned an error. We just know that it's something returned. Well, then we can mock that behavior and say, OK, we expect the update method to get called, and we want it to return true. And this way, we can pinpoint the critical part of our program and test it. Which leads us to the question of what are stubs, when to stub something and when to mock something. A lot of smart people, including Catherine Novan and I forgot all the computer science guys, came up with this table. You can think of all methods that exist you can put them in two categories. They're either a query or a command. A query returns a result. So for instance, if you ask your database to return all your users, that's a query. But if you try to update a user, that's a command because it changes state. And you can also think of methods being incoming and outgoing. So if you're testing an object, incoming methods are the methods that are being called on you. So if you're testing a user and you want to test its set password method, that's an incoming method. But if that set password method calls another object, for instance, crypto method, that's an outgoing method. Or basically, you can boil down this semi-complicated table into this much easier to understand table, which basically states that there are return values and change states methods, and there are methods, your own methods and others' methods. If you test your own method, you should always assert it, either for value or for side effects. But if you have external methods and they are return a value, so they're a query, you should stop them, and if they change state, you should mock them. Why is this so? Well, if you think about it, return values from external methods should be stopped because you don't know what it's going to return, but you, like what the actual implementation is going to return, but you know what you expect it is going to return. And why should we mock external methods? Well, we want to be certain that something happened. Because it's hard to replicate the changed state, but we can assert that it really tried to change it. This leads us to the example before, where you can see that we really did stub out and mock the correct stuff. Well, when you think about it, mocks and stubs give you many advantages. For instance, isolated testing, separation of concerns, speed, and flow control. Flow control being the most important feature here. But then again, they bring you many drawbacks, which I'll come to in a minute. But first, let's go over spies. Some people find mocks unwieldy. That's because if you think about it, when you mock something, actually your test part, like the actual code that tests something, is in the middle of your test. So it's here. And people find it kind of weird because we are all used to writing, setting up our test, executing code, and checking if something happened. And that's what spies do, basically. They allow you to stub out the behavior and then test if that stubbed out behavior got called. Some testing frameworks also implement dedicated spy objects, which are basically the same as doubles, but with a slight difference. Doubles usually raise an error if you call a method that doesn't exist on it, while spies will be completely happy to accept that method, and then you can check afterwards if it got called. Basically, doubles behave more like objects, and spies behave more like, well, I would say sponges. They will just accept everything. Now we come to the problematic parts with stubs, mocks, and spies. The biggest problem being that people, when they first learn about stubs, mocks, and spies, do a lot of errors. They test stubbed out, they assert stubbed out values, they create a mock, and then call the mock method in the very next line. And perhaps the biggest problem of all is that you can consider stubs, mocks, and spies as testing private methods, because you have to know the internals of your code to be able to stub or mock something. That's perhaps the best line here is a line from Spider-Man. I know it's cheesy, but with great power comes great responsibility. Also, another thing is that all the stuff I've talked about now is basically only for unit testing. And if you follow the guidelines, you know that 70%, every application should be 70% unit tested. But this leaves something to be desired. Basically, if you unit test something, this situation will happen. Two unit tests can work completely fine, but together they fail. This problem mostly arises in dynamically typed languages like Ruby. But for instance, in Java, where it's like a static type of language, this shouldn't be that much of a problem. But you should always create integration tests. Stubs, mocks, and spies are no silver bullet. They will not save you from writing integration tests, but they will help you control and test individual complex situations in your code with ease. Yeah, well, that's it. Thanks for listening.